So we're back to look at the p-value approach. The p-value, I put it right here, is equal to chi-sq dot dist, D-I-S-T, dot rt, dot, or excuse me, parentheses, and then you tell it the test statistic, which was 121 in our case, comma the degrees of freedom, and the degrees of freedom is 5, take away 1. So there you go. Now that's new Excel. If you have an older version of Excel, it'd just be chi-dist, C-H-I-D-I-S-T, and then again the test statistic, which is in cell G11 for me, comma the degrees of freedom, which is D8 minus 1. Okay, you're thinking, well, boy, those functions see the same. Sure they do. The chi-dist function works really well with right-tailed tests. It doesn't work nearly as well with left-tailed and two-tailed tests. Okay, so what does this mean for us? This is really, look at that, that's scientific notation. It's 0.0000024 zeros, right? And then a 2. So we are totally going to reject the null hypothesis because our p-value is essentially 0. It's not 0, but it's really close, which is lower than alpha, which is only 0.05. Now that means that we have our answer to A, because A was asking us, matter of fact, let me bring it back up so you can see it. Does the distribution of fatal injuries for riders not wearing a helmet follow the distribution for all riders? Okay, well, if we go back, you can see this is what we observed for people that were not wearing a helmet. This is what we expected for all riders. Now notice, were they the same? The answer is no. There's sufficient evidence to support the claim that the distribution of injury locations is different, or excuse me, injury locations for those riders not wearing a helmet is different than expected for all riders. Right? So the expected list came out of what we were expecting from all riders no matter what, and then we found that the observed for people not wearing a helmet was different than that. And part B, if you want to go look at it, it's asking, look at the expectation and the observed, where do you see the big differences? So the big differences, well, it doesn't really come right out and say that. It just says, here, compare observed and expected counts for each category. What does this information tell you? So let's look at this. Where do you see some big differences going on between what we observed for the non-helmet users versus what we expected? Well, the multiple injury is a little bit lower, and so is the neck and the lumbar and all that. But why? It's because look at the head injuries. When you're not wearing a helmet, you're much more likely to die of head-related injuries. So you're much less likely to die of all the other injuries, right? So the big difference is non-helmet, this is going to shock you, but non-helmet users are much more likely to die from head injuries. And you can see the really big significant difference right here in this column, because the biggest difference is going to be the biggest number over here for our observed minus expected. See how big that one is? It's huge. That's your most significant value. That's what's really causing everything else to go haywire. It's because the head injuries goes way up. Alrighty, so we've answered that question and we are done with 12.1 number 15.